symmetry. And by looking at these pictures, and plus I think you already know what symmetry kind of is. In a very short phrase, somebody tell me what symmetry is. What do you think it is? Symmetry. What do you think it is? Yeah, when you fold the paper, it just matches up exactly. So in nature, I don't know if butterflies are exactly. Maybe they are. I don't know. That's pretty cool. Are they? You're very, very close. I know that. If you put the line down your face like this, we are reasonably symmetric. We're not perfect, but we're reasonably symmetric. We can draw a line here, and we can fold it, they match up. That is symmetry. So we're going to look at 3 different types of symmetry. We're going to look at line symmetry, rotational symmetry, and point symmetry. So, right here's a dog demonstrating line symmetry. Occurs when a figure can be mapped onto itself by a reflection over a line. We call this line the line of symmetry. So this is kind of what you were describing, Rachel. If you fold the paper, that's line symmetry. It kind of maps right on top of each other. So here we go. You fold the figure, holding that line 2 has to coincide. You can have no line of symmetry. Something is not symmetric at all. You might have one, and you might have more than one, depending on what you're looking at. This little dog, you've just got one line of symmetry there, a vertical line of symmetry. So here's some examples of line symmetry. So in nature, we can see in butterflies, right? There's a line of symmetry. Whatever this thing is. Well, there's like this thing on this. It's real hard to see on the picture. I think we've got another line of symmetry, though. I don't know exactly if we've got more antenna on one side or the other, but I think there's some creature on here. Okay. So we have more than one line of symmetry on that side. The alphabet, and we'll be looking a little bit more at the alphabet for lines of symmetry. But, you know, you can have an A and fold it along. We call that a vertical line of symmetry. A B can be folded horizontally. That's a horizontal line of symmetry. And some letters have both. You can have words that you can fold in a vertical way or in a horizontal way.
Radar.
Well, we got, that's a good one. Wait till we get to this page about that, because let's just bring that up now. What kind of symmetry are you saying this time was?
And with this part.
Well, is it?
Lines.
Sorry, Bobby, could you send Leah to the house office, please?
Okay. Is this one have symmetry? Okay, because if I go this way, they don't fold on each other. Now, I know what you're thinking of. He's thinking of words that read the same backwards as forwards. So there's a sort of symmetry with that. But if we're strictly looking at it, if I fold the paper and I line them one up to the other, does it have symmetry? Not really. So it's a different kind. It's like an English teacher would say, yes. The letters go back and forth, but they're not. Polygons have symmetry. So I've got a square here, and I've got several lines of symmetry. Like there are different ways I could fold it. It would be exactly the same. Now you actually looked at something called an axis of symmetry when you graphed what figures? Remember this last year? No? What were we graphing that had an axis of symmetry? No? Nobody remembers? Oh, what's that thing called? Parabola. They have a line of symmetry and axis of symmetry as well. So not like you've never seen this before. You just forgot. All right, so speaking of letters, let's see if we can do this little exercise here. I'm on the middle of page 1 here. How many capital letters of the alphabet show vertical line symmetry? And I put a little alphabet there so we can look. Like, does this one have it? I don't know. Wait a minute. All right. What else? Does this one have vertical? No. So do you have any? What? Oh, H. H. I. Oh, yeah. Okay. That's an O. No. T. U. V. How about W?
11.
Okay. And Y. Now, did I get them all? Yeah. So you can kind of figure it out. Now, what about the horizontal line of symmetry? Now, some of them, it depends how you draw them. If you draw B like this, it probably does. This one, maybe not. I'm going to say yes. How about C? Again, I'm looking at it now horizontally. What else? U. E. That doesn't work, right? H. How about I? Ooh, look at that K. see they call now you see them. S, good one. S, does S have it?
No.
It does, if you fold along the line on the S, they don't line up, but I think you're seeing something else with S. This one, X maybe? Is that it? See if we found them all in there? I think we did. Now, how many of them have both? They're horizontal and vertical line symmetry. And you know what? We're kind of looking at the intersection of these two sets of letters, aren't we? We're remembering our Venn diagram. Is that everything? Hope so. Right? Now, we can have whole words that have it. Now, you try with radar. How about words like mom? Well, does race car have symmetry in the way that we're talking about symmetry? If I fold along a line here, do I get an exact match? If I fold along a line here, do I get an exact match? Not, we're looking really at the shapes. We're looking at the shapes rather than what it's kind of saying. Backwards and forwards, that's something else. Palindrome, right? Is that what that's called? Yeah. So this one has a horizontal symmetry. This one also. Vertical. What other words can we think of that perhaps has some kind of symmetry to them? Vertical or horizontal? And all my letters up there if you want to just kind of, you know which ones sort of work, can you make letters out of them? Yeah. Which one? B, E, D. So what kind of symmetry? If I fold here, does that work? So does this have horizontal? Yeah. Good? Please. Now which kind? Vertical, horizontal? Horizontal. Yes? Bob? Sure? Well, a lot of these horizontal ones are vertical ones. Yeah? Taco cat. Taco cat? Now again, taco cat, I think this is one of those palindromes. Now look, if I fold here, do all the letters perfectly line up? I think the C messes you up here. And plus it's no such thing. Taco cat. Yes. Yeah. Vertical. Well, do the G's line up?
No.
Ah, I know. And it's not as easy as it looks, is it? I have a few. Cookbook. Look at that. Checkbook. You like to play with that? This is, I'm told, this is the longest word you can find that has it. Florida, I think, right? Yeah. It probably is. Probably comes from a Native American word. So we're looking at we're not looking at palindromes. We're looking at if you were to physically fold them, do all the points line up. That's what we're looking for. Alrighty. So line symmetry examples. How many lines of symmetry, if any, do they have? So if we're drawing lines of symmetry, can I draw a line that you get a mirror image on each side? Here's one. Can I draw another one? There's two. There's three. There's four. And there's five. So it looks like I can draw 5 lines of symmetry on this. I guess it's a seesaw. Not starfish, because I don't like to say anything else than that. What's that thing on SpongeBob? What's it name? Patrick Star. Patrick Star, right? Yeah. They're very smart at SpongeBob. They never call sea stars. All right, now this guy, he's a little bit trickier. So I got a flower, so I can see these. So there's 2. I can see one's here. There's 3. There's 4. But I also can, I can see one's in here. 4, 5, 6, 7, 8. So this one has 8. This one has 5. How about this guy? How many lines of symmetry can we draw here? This is a 1, 2, 3, 4, a hexagon. Yeah. What do you think? 2. Where? Yeah. Do you have any others?
4.
But does this work? They're not going to line up if you fold on that line. So you always kind of have to visualize. If I fold on that line, will it get there? Here's another hexagon. So we have the same ones, right? There's 1, 2. But this one will have more. Because it is regular, and we can get one. 1, 2, 3, 4, 5, 6. This one has 2. This one has 6. And then how about example to be symmetric. Most things, I guess, are not. So let's try to see if we can draw any sort of inductive conclusions here. How many lines of symmetry does a regular n-gon have? How many? N. And how many lines of symmetry does an n-gon have that has no equal sides? The opposite of regular, yeah, none. Does not have any. So when you're looking for basically congruent sides as a clue to do you have symmetry? Alright, so that's line symmetry. Let's look at rotational symmetry. Okay, rotational symmetry. An object has rotational symmetry if there's a center point around which the object is turned, rotated, a certain number of degrees, and the object looks the same. Alright, what? Okay, so here's like a little example of that. The order of symmetry indicates the number of positions. Okay, so this guy here, does he have rotational symmetry? If I kind of wind him up 90 degrees, what happens to him? It's this, right? Do they look the same? That's rotational symmetry. If you turn it a certain amount and you get the same thing, then it has rotational symmetry. The order is how many positions can you turn it and it looks the same. I can turn it once, twice, 3 times, 4 times. This shape has an order of 4 because I can turn it 4 times around. Alright? And then we look at, well, what degree measures? So at 45, do I have rotational symmetry? It's not the same. So I do it 90. If I was to go at 135, would I get it? No. So I'd have to go 90, 180, and 270. These are the degree measures that give me different, it's different shapes or different turns. I don't say 4 because 360 gets me right back where I was. It's the exact same shape. So 360 I don't really count. So if we look at some of these examples here, these are on your paper on page 2. I got the shape here. Does it have symmetry? Rotational symmetry. Can I turn it and get the same shape? Yes. So what's the order? How many different ways? 4. And what is the degree rotation? 90. Or I could go 180. Or I can go 3-way, 270. Those are my rotations. What about the order of this guy? Is that the hospital sign? How many different ways can I turn? Yeah? 2. We've got an order of 2. I turn it once, I can turn it upside down, and I can turn it right the way around. This only has a 180-degree rotation, and then I'm back up. This is looks like a roundabout little symbol here. So how many, a traffic circle, what do we call it? There are all those different little ways to call these little things. Do you have a roundabout? So can I rotate this and get the same thing? How many times can I do that? How many? 3. So let's see, so what's that rotation here? Now, how am I getting these rotations? How am I getting these values? I know all the way around is 360, right? Yeah? Yeah. Divided 360 by 4 is divided 360 by 2. What's 360 divided by 3? 1. Okay. I can go another 120. I'm at 240. And then if I do it again, I'm back at my 360. I don't need to stay that exact. 360, I'm back where I started from. What about the little horsey thing? Order 1, which means there is no rotational symmetry. There's no way I can turn this other than to bring it back right way around to do that. So it's kind of like a 360 rotation, but in essence there really isn't any rotational symmetry here. No rotational symmetry for all horse animals. Alright, so geometric figure has rotational symmetry if the figure is the image of itself under a rotation about a point through any angle whose measure is strictly between 0 and 360. Basically, you're turning it circular direction, and you get the same thing. So for a regular polygon with n sides, what's the order of rotation going to be? This is a hexagon. How many times can I turn this guy around? So what's this going to be? N. So if you have a regular polygon, it's got n sides, it has an order of n. which is its number of sides. As we discovered, you find the degree by dividing through 60. So a hexagon has 6 sides, has a degree, order of 6. So its degree of rotation is what? 60. What else? Right, I can turn it 60. What else can I turn it? Yeah? 120. What else can I turn it? 180. What else? God, I have 60 this way, 240. What else? 300. Now, if I turn it 6 all the way around and 360, that doesn't give me a different position. That's the same. So I don't include the 360 rotation because that's the same where I started from. It's not different. So it shows all the different ways you can do rotating. That's kind of it for rotational symmetry. Point symmetry is every point has a measuring point the same distance from the central point. We actually kind of talked about this before because it's the same as 180 degree rotational symmetry. Something with an order of 2 rotational symmetry, like the H sign when we look at the archive. It has point symmetry. And another way to think about it is it looks the same upside down. Point symmetry, if you turn it upside down, or in the opposite direction, I guess, think of it going this way. It's the same upside down. It has point symmetry. Same thing upside down. Let's look at some examples. Now, we saw this guy already. So does this have point symmetry? Does it look the same upside down? So you look at that 180 degree rotation. For point symmetry, this is the one I care about. Are they the same? So it has point symmetry. Same upside down. Does this thing have point symmetry? And, you may have to upside down, but take a look. Maybe turning your fingers upside down. Does it have point symmetry? Do all playing cards have point symmetry? Maybe. Some do, some don't. Some words have this point symmetry. Look at this guy. Turn this guy upside down. Does it have point symmetry? This one. No, it's not the same upside down. So wow, it's still pretty cool, but it's not point symmetry. How about no? Turn it upside down. Turn it upside down. Yes. Swims. Oh, look at that. I'm upside down. It still says swims. Yes. This is kind of neat. Alrighty. I mean, that's basically all there is to say about this stuff. So go ahead and try these. Answer the questions. Is it rotational? If it does, find the order of rotation and the degrees of symmetry. Does it have point symmetry? Answer the question. It shouldn't take you long. So I'm just putting up some of the answers here. How do we do at least on ABC? We get first one, order 2. It does have rotational symmetry, order 2, 180 degrees. Second one has an order of 3. Right? 120 degrees, 240. This little hubcap thing. Order 5, 72 degrees. 144, 216, 288. Guess so. Let's look at the other ones here. This one looking more with the point symmetry. I love this little graphic here. Now no swims on mud. Turn it upside down. What does it say? Now no swims on mud. So yeah, look at that point symmetry. It's the same thing upside down. Do these have point symmetry? Does math have point symmetry? No. Does moon? Well, turn it upside down. Just the paper. You don't have to turn yourself upside down. You can turn the paper too. Which cards, if any? Now the hearts don't because these shapes are not symmetric. So when I turn that heart upside down, or the shape itself does not have point symmetry, it is symmetric. It has a line symmetry, but it's not a point symmetric thing where